Have you ever wondered how your emails, streaming videos, or even simple search queries manage to travel across vast networks to reach their destination? It is an incredible journey, and at the heart of this global navigation are devices constantly making smart decisions. At its core, a routing table entry primarily contains a destination network, a next hop address, an interface, and a metric. These four pieces of information empower routers to correctly forward data packets across complex networks. Let us break down why each of these is so crucial. The destination network tells the router exactly where the data is ultimately trying to go, identifying a specific network block, not just a single device. This is often represented by an Internet Protocol address and a subnet mask, defining the entire network segment for which that route is valid. Without this, the router would not know which target group of devices the packet belongs to. Next, the next hop address, sometimes called the gateway, indicates the Internet Protocol address of the next router on the path toward that destination network. Think of it as the instruction to pass the package to a specific postal worker who is closer to the final recipient. This is an essential guide for the data's immediate step. The interface specifies the physical or logical outgoing port on the router that the data packet should use to reach the next hop or directly connected destination. This could be an Ethernet port, a wireless interface, or even a virtual tunnel. It is the physical exit door for the packet to continue its journey. Finally, the metric is a value that quantifies the cost or preference of a particular route to a destination. Lower metric values usually indicate a more desirable path. This cost can be based on various factors like hop count, bandwidth, delay, or reliability. Routing protocols use these metrics to compare different possible paths to the same destination and select the most optimal one. For example, a path with fewer hops or higher bandwidth might have a lower metric and therefore be chosen as the preferred route. When a router receives an incoming data packet, it examines the packet's destination Internet Protocol address. It then compares this destination address against all the entries in its routing table. The router looks for the longest prefix match, meaning the most specific route that matches the destination network. Once a match is found, the router uses the associated next hop address and outgoing interface to forward the packet. If multiple paths exist to the same destination, the metric helps the router decide which route is best. This intelligent lookup and forwarding process is what allows data to traverse multiple networks efficiently. An interesting detail is the concept of a default route. This is a special routing table entry that acts as a catch-all. If a router cannot find a more specific match for a destination network in its table, it uses the default route. This is like telling a postal worker, if you do not know where to send it to the main sorting office. It is often represented as 0.0.0.0/0 or 0.0000/0. This ensures that every packet has a chance to find its way, even to unknown networks. Routing protocols like Open Shortest Path First or Border Gateway Protocol actively exchange and update these entries between routers, keeping the network maps current and optimized. Understanding the key data within a routing table entry is fundamental to comprehending how networks operate. It highlights the intelligent decision-making process that enables seamless communication across the globe. These simple yet powerful pieces of information ensure that your data packets are not just randomly sent but are carefully guided along the most efficient and preferred paths, making the vastness of the Internet feel remarkably small and interconnected.
If you love understanding how the web works, like, subscribe, and stay connected with us.